Now, Dr. Wong Seo Kim, and after the question.
안녕하십니까. Don't worry about the translation. I'm not gonna present in Korean from now on. Speak English. Good afternoon, ladies and gentlemen. I'm Wong Seo Kim from Korea Ocean Research and Development Institute, and I'm a former director of Marine Resources Research Department. I was a biologist, but now I'm working more on administration work rather than the scientific work. Well, originally, Dr. Jungkook Kang, the president of KORDI, was supposed to present on the Korea's effort. Where is my slide? On the title of Korea's effort to develop marine mineral resources in this seminar. But due to his busy schedule, I will do that on behalf of him. Well, first of all, I'd like to thank International Seabed Authority and Brazilian government for invitation. It's the first time for me to visit Rio de Janeiro, the famous city for the 1992 summit regarding to the environmental issues. And I think the Copacabana beach is too beautiful to keep the participants in this seminar room. But fortunately today we have rainy days. Well, Brazil is a special country to Korea. While in the morning, the Dr. Yves Fouquet mentioned the Jules Verne, the famous novelist, the French novelist, about 150 years ago. He wrote another science fiction titled Journey to the Center of the Earth. Probably all of you know that novel. If you drill or dig the Earth to the center and keep continuing, then you will come out to Korea. That means Korea is located in the exactly opposite side of the globe. So that means the day-night time is totally reversed, and the season also reversed. So it's time for me to get some sleep. So if I fell in asleep during the presentation, please wake me up. Okay, I will briefly introduce the KORDI, Korea Ocean Research and Development Institute, which I'm working in. Well, the KORDI is the research institute supported by the Korean government. And we have about 500 employees. Among them, about 300 have the doctoral degrees on oceanography, physics, chemistry, geology, and biology, and engineering, even the economics and the law of the sea. And the headquarters is located in Ansan City. It's very close to Seoul, the capital city of Korea. And we have 3 branches. One is in Daejeon. I know some of you know the Daejeon city. It's lots of the research institute of Korea get together in the city. And 2 other branches in the southern coast, and the other one is in the east coast. And also we have a joint research center in Qingdao, China, and the one in the federated state of Micronesia for tropical research. And also we have 2 research stations, one in Antarctica, the King Sejong stations for Antarctic research. The other one is in the Svalbard Islands in Norway for Arctic studies. Okay, next please. Well, I know that many participants of this seminar has a scientific background, but many of you doesn't have any scientific background. So I'm gonna start with my talk with a little bit of scientific background. Well, by this time, all of you have already known that the three kinds of deep sea bed mineral resources, because every speaker mentioned this. So the manganese nodules is found in abyssal plain with water depths of 4,800 to 5,200 meters. And manganese nodule contains various metals, and metal contents is here. I'm not going to mention in detail. And the values of manganese nodules is about 300 to 900 US dollars per ton. And the seafloor massive sulfide deposit is found in mid-ocean ridge, a trench, with water depths from 250 to 3,200 meters. And it contains gold, silver, zinc, and copper. And this value is from about 500 to over 1,300 US dollars per ton. Next, please. Next, please. Okay, here is the trend of metal demands in Korea. Well, since Korea has poor mineral resources, we have to import most of them from overseas to maintain its stable economic growth. The problem is that self-sufficient rate of metals in Korea have gradually decreased from 16.4% in 1983 to 0.55 in 2000. And we expect that the self-sufficiency rate dropped down to 0.04 in 2010. It's a terrible situation in Korea. And the data indicate that we depend on our demanding metals totally from foreign imports in the near future. And we spend a lot of money to import the metals. For example, we spent 683 million US dollars in 1983 and more than 5,000 US dollars in 2000. And it will increase about 3 times in 2010. Next, please. One more, please. To overcome such problems of mineral supplies, the Korean government considered the exploitation of deep sea mineral resources as an alternative option for long-term stable supply of major strategic metals, and decided to build up our own technological abilities for the development of deep sea mineral resources. The Korean government decided to initiate deep seabed mineral exploration programs in early 1980s. Such efforts finally lead us to become the 7th pioneer investor country by registering the exclusive exploration area for manganese nodules to the United Nations in 1994. I will talk about history of developing marine mineral resources in detail from the following slide. Next, please. Next, please. The period from 1982 to 1991 is an introducing stage. The Korean government decided to initiate deep seabed mineral exploration program in early 1980s, as I told you before. The year of 1982 is considered as the starting point of Korea's deep seabed mineral development. Adoption of the United Nations Convention on the Law of the Sea in 1982 was the trigger for the Korean government to start the deep seabed mineral development. Korea's first survey for deep seabed minerals was conducted in the Clarion-Clipperton Fracture Zone in 1983 by the Korea Ocean Research and Development Institute. After initial prospecting in 1983, however, the Korean government deferred any immediate actions, mainly due to the legal and political uncertainties, including the mine site conflict among the potential pioneer claimants and the ambiguity of the term of pioneer activities. No, the previous, not it. The previous one. Previous slide, please. Okay. In 1989, Korea resumed survey program for deep seabed mineral resources and carried out 3-year joint exploration with the United States Geological Survey, focusing on the cobalt-rich crust in the Marshall Islands and Micronesian Islands and manganese nodules in the Clarion-Clipperton Fracture Zone. This joint survey program was funded by the Korean government and USGS. The period from 1992 to 1994 is an entering stage. As the Korean government finally decided to develop deep seabed minerals in 1991, the Ministry of Trade, Industry and Energy launched a full-scale national program in 1991 for the exploration of manganese nodules. Korea was designated as a major operating institute for this program and conducted ocean policy researches related to the deep seabed mining and regional exploration for the manganese nodules in the Clarion-Clipperton Fracture Zone. The Korean Institute of Geology, Mining and Materials, KIGAM, I know a couple of the Brazilian scientists have already relationships with the KIGAMs for the joint research. And the Korea Mining Promotion Corporation joined Korea to cooperate in the survey program. With the acquisition of research vessel Onuri in 1992, the Korea strengthened its capacity for surveying the deep seabed resources and related environmental studies more efficiently with the state-of-the-art deep seabed survey equipment. At the end of 1993, Korea finally selected 300,000 square kilometers of commercially prospective deep seabed mining area based on the result of the past 6 years exploration in the area of more than 1.3 million square kilometers. The Korean application for registration as a pioneer investor was approved by the General Committee of the 12th resumed session of the Preparatory Commissions on the 2nd of August 1994. As a result, Korea secured the exclusive exploration area of 150,000 square kilometers for the manganese nodules as a Korean registered area. Next, please. The period from 1995 to 2002 is a take-up stage. In this period, manganese nodule program was mainly focused on the resources potential assessment to implement the scheduled relinquishment of the Korean registered area. During 8 years of detailed regional survey in the Korean registered area, Korea successfully conducted 3 steps of relinquishment and finally selected the Korean contract area of 75,000 square meters in 2002 for further detailed explorations. 75,000 square meters is pretty big areas to Korea. It's almost two-thirds of the area of Korea. I know the Brazil is a big country, but the Korea area is too small, so it's a huge areas to us. Manganese node reserve in the Korea contract area is estimated 510 million tons, which can be mined for 100 years at a yearly production rate of 300 million tons. If we mine 300 million tons per year, the recovered metals are estimated to have a value of $1.5 billion based on 2002 metal price. In 1996, the Korean Deep Seabed Mineral Development Program was transferred to the Ministry of Maritime Affairs and Fisheries, a newly established ministry of the government. The birth of MOMAP provided a good opportunity to facilitate mining and processing technology as a part of the Deep Seabed Mineral Development Program, and to enlarge the other programs for cobalt-rich crust and seafloor massive sulfide. Exploration programs for cobalt-rich crust and seafloor massive sulfide started in 1999 and 2002, respectively, as a long-term government R&D program. The period from 2003 to present is a growing stage. Since Korea determined final allocated areas in 2002 for manganese nodules, exploration has been focused on finding commercially exploitable area by using GIS-based integrated data evaluation system. Several pilot devices, such as lifting system and nodule collector, were manufactured, and we have a plan to test them in a shallow sea next year. Manganese nodule processing study was also conducted to design new refining processes. Cobalt-rich crust survey was mostly conducted in the Magellan Seamount area of Western Pacific until 2004. However, this program was temporarily suspended in 2005 in order to put concentrated effort on the research of seafloor massive sulfide, which is commercially most exploitable mineral resources. Also, due to the delay in the enactment of mining code for cobalt-rich crust in the International Seabed Authority. We are currently expecting to resume our crust program in 2010. Seafloor massive sulfide survey was initiated in 1998 as a CORDIS R&D program, and it was converted to a long-term government R&D program in 2002. As a seafloor massive sulfide is emerging as a new deep sea mineral resources to be developed earliest among all three mineral resources, such as manganese nodule and cobalt-rich crust and seafloor massive sulfide. Since 2002, seafloor massive sulfide survey has been conducted in the EEZ of Fiji and Tonga. Recently, Korea acquired the mineral prospecting license for seafloor massive sulfide in the area of about 19,000 square kilometers from the Tonga government in March 2008 this year. Next, please. Okay, next, please. Well, I just missed one slide. Please backward. Okay. Well, it's our future effort to develop marine mineral resources. We'll carry on for the survey in our nodal areas for the environmental impact assessment due to commercial mining of polymetallic nodules. Our mining devices will be tested in deep water conditions, and technology will be upgraded for commercial mining of polymetallic nodules. Also, mining technology for seafloor massive sulfide and crust will be developed using mining technology accumulated in the nodal area. Although we are currently surveying seafloor massive sulfide in the each of island nations of the South Pacific, we will soon begin our seafloor massive sulfide exploration in open sea area of Indian Ocean. For such new challenges, Cordy is now designing 4,000-ton class new research vessels. Next, please. Now I'm going to talk about manganese nodules in detail. Polymetallic nodule contains variable metals, as I told you before. Average manganese content in the nodule is 27%, and iron is 8%, and such like that. And the three most valuable metals in the nodules are copper, nickel, and cobalt. Its total content is about 3%. Next, please. The red rectangle is Korean manganese nodule survey areas. It's located in the Clarion-Clipperton fracture zone. It's about 2,500 kilometers apart from Hawaiian Islands. Next, please. I just have 3 more minutes. I'm in the middle of my presentation. Okay. One more clip, 2 more clips, and 3 more clips. Okay. Well, this slide shows brief history of manganese nodule programs. Well, I'm not gonna explain in detail. I will skip to the next slide. Okay, one more clip. Clear again. Okay, here is the register area for the manganese nodules, and it's the Korean contract areas of 75,000 square kilometers. It consists of 7 blocks. Next, please. This is what we are doing for prospecting survey for the polymetallic nodules. We are working on the bathymetries and nodule distributions and the evaluation of resource potentials, and also making the GIS-based integrated data evaluating systems. Next, please. Okay, now we are developing the mining systems, and also we are doing the environmental studies to evaluate the environmental impact assessments in our areas. Next, please. These are the equipment for the field survey, and probably you're familiar with this equipment because previous speakers mentioned this equipment. Next, please. And it's the developing pilot scale mining equipment. We are developing the 1 to 20 scale pilot model miners, and also we are developing the lifting systems. Next, please. Okay, one more clip. It's a multiplex cinemas. Well, on the right, you can see the lifting systems to test the in the shallow sea conditions. You can see the crush the polymetallic nodule particles going up through the lifting systems. And here is the scale pilot model miners working on the soft bottoms that we make artificially. Next slide, please. It's the defining process that that the KIGAM developed newly. Next, please. And also through these programs, we are developing the ROVs for the use of to develop the marine minerals. Next, please. They can dive down to 6,000 meters. Okay, now is the current stages of manganese node development. Well, I think I've already explained this. Okay, I will move to the next slide. Okay, further exploration for cobalt-rich crust. Here is the areas that we have done the field surveys. Next, please. And it's the study areas. And next, please. We surveyed 14 seamounts out of 63 in these regions. And each symbol means the size of the seamount. Next, please. Well, to evaluate the resources in the seamount, we are doing the bathymetry works and also using the deep camera systems. We figure out the vertical distribution pattern of the crust and also slope analysis. And we are also doing the horizontal distribution pattern analysis using the dredge samples. Next, please. Okay, as I told you, the crust program now is suspended and will resume in 2010. Next, please. Now I move to the seafloor massive sulfide. Well, probably you have interest in the SMS business, so I will spend some time to explain. There are two steps. We conducted preliminary surveys as a Cordis R&D project from 1998 to 2000 for 3 years. Field survey was done in Yap Trench of Micronesia, Manus Basin of Papua New Guinea, and Udulak Basin of Solomon Islands. From 2002 to present, as a Korean government's R&D project, we are conducting exploration activities in North Fiji Basin of Fiji and Lao Basin of Tonga. Next, please. It's the map of the study areas. Next, please. Well, since 2002, field survey for seafloor massive sulfide has been conducted in the EEG of Fiji and Tonga. Recently, Korea acquired the mineral prospecting license for the seafloor massive sulfide in the area of about 19,000 square kilometers for Tonga government in March this year. The red is for Cordy, and green for Nautilus, and the blue for blue metal companies. Next, please. Well, I'm gonna skip this. Skip again. Okay. It's the vision of Korean deep seabed mineral development programs in general. We do our best to get the fruits from the deep seabed for stable supply of the mineral resources. In order to do that, we've established foundation for commercial mining and introduce new marine industry and spinning of new technology. But we always keep in mind that the development of deep sea mineral resources should be in a sustainable mode. We'll consider environment first. Next. Okay, I will skip this. Okay, now is concluding remark and some suggestions. Oh, not yet. No. Backward. Okay, one more. the exploitation of deep sea mineral resources is still risky in the viewpoint of economy and technology. This problem is partly due to the economical and technological uncertainties associated with our lack of knowledge. However, we expect that such difficulties will be overcome as technology and experience accumulated from lots of researches and field surveys by research institutes, universities, and companies in the world. Unfortunately, such effort of developing deep sea mineral resources have been conducted separately by different countries' research institutes, which inevitably resulted in overlapped investment to the same research area in a global viewpoint. Next, please. Lack of cooperative efforts, as previous speakers has already mentioned, and sharing of accumulated knowledge, experience, and technology might be one of the reasons for the slow progress of polymetallic manganese nodal development. It is well known that various cutting-edge technology from various disciplines are required for the commercial production of deep sea mineral resources. Considering each country's interest and comparative superiority in different areas of technology, international collaboration between countries of common interest could bring technological achievement more efficiently with less cost. Regarding this, the ISCA's role as an organizer of these collaborations might be important. As ISCA, we have a plan to prepare joint symposium among contractors, especially 3 most active contractors for manganese nodal development, such as Korea, China, and India. Since CORDI started its first deep sea survey in the 1980s, it took almost 1 generation time to establish specific systems to develop deep sea minerals. CORDI will make its every effort to harvest visible outcomes from Korean Deep Seabed Research Program in the nearest future. Okay, I have a couple of more slides to show the equipment. I'd better quit at this moment. And as I told you at the beginning, the season is totally reversed. In my country, it's winter time, but it's summer. So I feel very hot and sweating. Okay, I'd better stop now. Thank you for your attention. Obrigado.
Congratulations, Mr. Wong Seo Kim. Congratulations, Dr. Shin Tani. I'm inviting you come to the table to answer the questions. And I am writing the names of the participants that would like present the questions. Okay, Kaiser. No, please. Kaiser. Please the names. Okay. Okay, Mr.
Koplinski.
Koplinski. Koplinski. Okay. Guys. Okay. Anybody? Anybody else? Oh, okay. Dr. Koplinski. Koplinski.
I have one question to the Mr. Shintani. First of all, I would like to congratulate very wide work of the deep sea mineral resources of Japan and use a new technology and very, very interesting, especially the bathymetric data was paralyzed for me. But my question is, could you inform us about result of Japanese research program of metal hydrides, please?
Methane hydrate.
Hydrates.
Methane hydrate.
Methane.
Methane hydrate.
Hydratos. And the next question. Okay, the next question, please.
Thank you very much for your very brilliant presentation, both of the presentations. I just would like to thank Mr. Tani, because when we contacted him, he told that he had a meeting before coming here and a meeting after, so he traveled 2 days to come. He stayed only 1 day with us and traveled another 2 days back to Japan. He must be a very big traveler, because he traveled a lot from Tokyo to his city, and he has taken us to this trip around the Japan Sea. So thank you very much. And thank you also for, indeed I have no question now, it's just to make this observation.
Just a small comment. Well, my home is a little bit farther than the Japanese going somewhere.
Okay, to the answers. Yes.
I got a question from Kovinsky on the methane hydrate development program. The methane hydrate was first identified in 1990 something, and since then the monitoring or research to locate the location, and also the development of the recovery system is being done. And this time of the year, the JOGMEC, which I showed, the JOGMEC, Japan Oil, Gas, Metal, something, made the experimental recovery the Canadian site. It's a land-based, and got the methane gas continuously for, I understand, 6 days. And they said that's a good sign. And they will use that technology at the sea bottom to recover the methane hydrate. But before doing that, because of the fragile sea bottom, you have to think about many things to avoid the disaster. And that's also being considered. The plan of Japanese national plan of the commercial production of methane hydrate was year 2016 or 18. And the plan is by then they will be ready to commercially produce the methane hydrate from some of the Nankai Trough area. Is it enough? And thank you very much for your work, Dr. Souza. My body is made of flight food. Only 1 day food here and 4 days food from the flight economy class. My body is made of.
Dr. Ron. Okay, then I'm on to the coffee break.
Yes.
Okay. Ladies and gentlemen, Mr. Dr. Jankai Jin of China. Please, Dr. Jin. Microphone, please.
Ladies and gentlemen, good afternoon. My name is Jin Kanji from China. First, I would like to express my thanks to the International Seabed Authority giving me this opportunity to visit Brazil. And my thanks also to Brazil colleagues for your hospitality and excellent organization. And the authority gave me the topic for the Chinese effort to develop marine mineral resources. But actually, I could not this topic beyond my capability, because actually I'm not dealing with these activities in the national jurisdiction area. For instance, some Chinese national company deal with gas and oil exploitation in the near or offshore, and also the China Geological Survey now conduct a national program for the methyl hydrates, also in the Chinese jurisdiction area. So my job is to deal with these activities for mineral resources in the International Seabed area. But my topic is that I give you a very general introduction about Chinese effort to develop mineral resources of the area. Next, please. So my presentation will give you some background of the Chinese activity in this area and what we have done and what progress we get, and then very briefly for our future workers. Next. And before my first topic, and I just wondered that what we recognize, what contribution could the deep sea or the area do for the human? I believe that this very large area can offer the new source of resources, including mineral resources and maybe in the future biological resources, and also give us a knowledge of the ocean. I remember the Secretariat once said in the United Nations Assembly that every time people learn, people have a new discovery of the deep sea, and we recognize how limited we learn about the ocean. So without the knowledge of the deep ocean, we could not say we learn the whole ocean. Then the third one is I think that the activities of the deep sea can lead in the development of high-tech and equipment of the ocean. And also, I think this year is that people more and more realize that this vast space can also give some part solution for the climate and the environment issue. Of course, then last but not least, we believe that the human civilization and the area can also stimulate the human civilization to establish the order and the regime and the rule and regulation and the procedures. Next. So talk about the background of Chinese activity in the area. Now, I would like to give some our interest why we did this. Next. We do the activities in the area. First, we consider that the National Economic Department, you know that China is a large country and we have a rich resources, but consider the large population. The average is very low, much lower than the world average. As a development Chinese economy, we need more that the mineral resources. So I think that our policy, and this is very important for our policy for the activity in the deep sea. Then the second, I think, the political or diplomatic consideration. The Chinese government always maintained pay much attention of the importance to the principle of common heritage of mankind. And this principle, and I think it's very important for our government or the people to participate in the development of this regime. And the third one, we think that the activity in the deep sea can create a new area for the technology and in the future, a new industry development. So this is our interest. The next. Then we started this activity in the deep sea. We have some assumption or some consideration. We believe that at the very beginning, we believe the activities in the area should or must be carried out under international regime based on the principle of the common heritage of mankind. Then, at the beginning, we started the activity in the deep sea very early, as early as the 1970s, late 1970s, and we did a lot of work in the 1980s. And at that time, the Chinese economy was not as good as now. But we believe that investment requirement during this research and development stage can be accommodated to the progress of national economic development and the regime, also the Chinese regime reform. Then the third assumption is that we believe that technology can be obtained as time is going and by different means. So this is some assumption. Next. But then I give some main events for the development of the activity in the deep sea. In 1980s, a survey entered the sea for the preparation of an application area for polymer technology. In 1990s, China Ocean Mineral Resource Research and Development Association was established, so that's a COMRA, and applied for a pioneer area for nodules, which was approved by the United Nations PREPCON in March 1991. Then in 1996, then China was elected as a council member of the International Seabed Authority in Group B as one of the largest pioneer investors. Then 2001, COMRA signed the contract for exploration of the polymetric nodules with the International Seabed Authority. And again, in 2004, China was re-elected as a council member of the International Seabed Authority. But at that time, we take the seat in Group A as the largest consumer of the relevant metals contained in the mineral resources in the deep sea. Next. The mission and the function of COMRA are, and the mission is the COMRA, open a new source for all the strategic mineral resources to meet the part demand of the national economic development. And the second is to promote the development of new high-tech knowledge industry in the future. And the third made its contribution to mankind by its activity in the international seabed. And the main function of COMRA as a coordinating body to coordinate the different departments, institutes, and the entities in the nation to carry out the activity in the area under the regime of the law of the sea. Next. So a translation to, we have a working guideline, but maybe not so correct. So we said that we insist and continuous for exploration or survey on the deep sea bed, and then to push forward the development of technology necessary for the deep sea activities. The third one is establish deep sea venture in appropriate time. Next. Now, I gave some introduction about what we have done or the progress we made. Next. And the main progress we made in this aspect is the exploration and the technology and the equipment development, and environmental assessment, and also capacity building. But also we have other progress, for instance, like something strategic studies or the obligation and implementing obligation as an investor for and now as a contractor. We we did something for implementing obligation. Next. For the exploration, since Commerce established, 20 survey cruises conducted since 1991 under the Commerce plan. And we covered the mineral resources. At the beginning, we started polymetallic nodules, and in the middle of 1990, we started to focus on other mineral resources, copper-rich crust and polymetallic sulfide, and data and sample collection for resources and environmental assessment. Also, with capability building for its future exploration activities. Next. For the polymetallic nodules, in 1991, Canberra reached as a pioneer to obtain a pioneer area of 150,000 square kilometers for polymetallic nodules. In 1997, the Authority Council approved the plan of work for exploration. In 1999, we completed the relinquishment of the claim area that we remained 75,000 square kilometers as an exploration area. So in 2001, we signed the exploration contract with the authority. Next. So according to the contractor, the exploration plan mainly covered including to collect the data and sample for evaluation of the resources and the environment, and evaluation of the resources, quality, quantities, distribution, and economic value. Also, environment baseline survey and environmental impact assessment. I designed the test mining systems, upgrading methodologically experiments. Also establish a database for our same criteria through internet cooperation. Next. So work on the contractor area. Since then, we identify 3 types of the topography that in our contractor area, and all the epicenter hills, sea mountain chains, and episode basins are recognized in the contractor area. And also we found 5 types of surface sediment occur in the contractor areas, and also different type of the sediment located in the different region in this contractor area. Next. This is topography of the east part of our pioneer area. Next. That's the west part. We actually, our areas divided is separated in the west part and the east part. Next. We also done a geological models cooperated with the authority and the EEC. That the common contractor area complete the seafloor topography map and the sediment distribution map, and using 3-dimensional modeling technique to display the key models results and complete the local scale high resolution methods. And also development the spatial division support system modeling and the prediction of the potential nodule resources in the EEC. The distribution principle of the mineralization's favorability of potential undiscovered nodule deposited in the EEC as a whole is predicted. Next. And our scientists also made a growth model of the nodules, and this is where our scientists expected to further cooperation with the authority. Next. And our attention also to the other resources. From, as I said, from early 1990s, Congress started the exploration, assessment, and the study for other resources, mainly for copper-rich crust and polymetallic sulfide. And this is the survey area for the core. Oh, next. This is the survey area for copper-rich crust, mostly in the middle Pacific Ocean. Next. And this is the main 2 different types of the sea mountain. One is very flat, other is more roughly. And the next, this is the sample we take, different type of cooperative rich crust sample. Next. Next. And that 2 years ago, we organized a world-round cruises, and mainly emphasize, mainly attention to focus on the survey for the polymetallic sulfide. So far, we found some 2 areas in the eastern Pacific Rising and also southwest Indian Ocean in the Mediterranean region. There's some sulfide deposit. Right now, our vessel is still working in the ocean. This is some sample we took. Next. Next. This is the photos by the TV sample. Next. So the progress made for the second aspect is the technology and the equipment development. And from very beginning, I think the equipment we used most import from other countries. Then as the time is going, we began to study and research this kind of equipment ourselves. And this is including the survey equipment and mining technology and the process technique. Some survey equipment. Next. This I show that some survey equipment, I think most we did ourselves, our scientists and engineers, that made some. Okay. Yeah, I just want to make a little explanation because I saw that in the Chinese. That one is 6,000 meters autonomous underwater vehicle. And this one is TV and camera. For this is the shallow stage of drilling, especially for the crust. Especially for the crust. And this is for measure the characteristic of the deep for the seabed. And this is multi-core and the sample. And this is a TV crab or TV sample. And this is 6,000 meters and deep tour. And this is a sediment tremor. Next. So for the mining technology that we compare with the other method, the hydro pump lifting system appears with some, we believe, some potential advantage. And also conceptual design of the subsystems, the details design of the component and the verification of testing for the design. And also we did some virtual reality research for the mining system. And also we are working out a working plan and the relevant management strategy for the 1,000 meters sea trial. We finished our test in the lake and also design of the surface supporting subsystems and the determination of the technical specification of some key part of the system. Next. This is what we have done for, I forgot to say, this work in the sea, in the bottom. This is lifting systems. Next. For the processing techniques, we have pre-pilot test of the metallurgical process for the nodules, and a comparison test on the meteorological process of the polymetal nodules, and study of the new technology for nodules and direct utilization of nodule, and study of the nodules characteristic in the absorption and degradation of the organic in the western water. Also, processing technique for Coverdale-rich crust and polymetal sulfide is under development. Next. And then I think one of the main work is the environmental assessment. And we have carried out a program called Natural Viability of the Baseline, focus on the collection and analysis of the biological, oceanographic, and geological baseline data. Almost every survey cruise, data collection, we collect the data and analysis of the baseline. This includes biological and chemical and physical parameters. Next. So environment program consider both in the also in design of the mining system and in the research of the meteorological circles, the marine environment impact possible caused by the deep sea and mining activities, and the form and amount of waste from mineral process and metallurgy, disposal process of the residues from the mineral processing and metallurgy. Next. And another progress made in for capacity building. This is our main vessel, so we call it Danyi Hall, and imported. We bought it from Russia in 1994, and then we made several times renovations. And right now, I think it's the best research vessel in China. Next. This is some equipment in these vessels. Okay, I see that in English. Next. Also, we now and we have to carry out a program called Human Occupied Vehicles, and of course there's a main task. And the progress we made now is that we have finished design, the manufacture, and assembly. And we finished the open water tank test, and we are now ready for the sea trial. And this is what we call the HOV. Oh, next. This is called the HOV. And the main specification is that the max operating depth is 7,000 meters. And okay, I'm not read that. Oh, next. Oh yeah, this is the main specification. Next. So this is the assembly of the HOV. Next. This is the process of the test. Next. The capacity building, we also made a deep seabed sample repository and built it in the Qingdao. I think this is also the first one in China for the ocean, especially deeper ocean. Next. And also we, in order to provide a scientific research program with data information, CONRA has established the China Deep Ocean Data and Information Database. This is a network. I'm sorry that again in Chinese, but roughly. Next. So having said the progress made, then I just want to say a little about the future prospect. Next. I think that I made some observation when we talk about prospect. I believe that in large picture for resources and their knowledge you see now. And strength awareness of the biodiversity. People talk about a lot about this issue and environment protection. And then the third one is the Interregional and International Seabed Authority play more and more important role in governing areas' activities. And the fourth one is the technology and equipment for activity in the area, recently quite fast development. And maybe the last, my view is we lack of doing. We talk a lot of, always talk about, we not lack of ideas. We have a lot of ideas for the international cooperation. Now, I believe that this is my personal view. There are some features of deep sea activity at current stage. The first is that I think that the mutual connection of the national and the international actions. Then for the jurisdiction, because I believe that at the beginning, I always give my colleagues the figure that such a give us. That means how to say. The area is covered nearly half of the surface, of Earth's surface, 49% of the Earth's surface. At that time, I believe that the precondition is that all the national jurisdiction is 200 nautical miles. Now I believe that if the continental shelf is now, I mean, this area, the size of the area, I think it's changed. So I think the large of the national jurisdiction and the small of the international seabed area. Then I think that another one is why mutual connection national and international actions. We know that right now some countries in some national jurisdiction, their activities for the sulfide and other mineral resources activities. And this is maybe have some influence for the regime and technology development and even commercial time for the international seabed area. The second feature is that now we found that more and more close connections of the resources and the environment assessment. So without the assessment for the biodiversity and the environment where the mineral resources exist, then it's very difficult for us to make the evaluation of the economy of the mineral resources itself. And then when we talk of the development of the mining technology, if we don't know the environmental biodiversity, then I doubt the effectiveness of the mining technology we design. So the third one is that we need some innovation of the international regime. So I think in this years people talk a lot about do we need another implemental agreement of the law of the sea convention for the biodiversity and the environment issues, and how to maintain principle of the common heritage. I think that such a seminar is a very good example for reflect the principle of common heritage of mankind. So man work in the future